Okay. So we proceed. We are on 3. Kindly mute yourself. So we are on 3C. So went as far as this point, x to the power 8 minus 3r over 1 by y to the power negative, then 8 to the power, we add the 3r minus 8. Okay, we say this is over 1. So we had 8 minus 3r. This is over 1. So we have 8 choose r, 1 over 3 to the r, x to the 8 minus 3r over 1. Then this part here, the power is negative. And so when we write 1 over the same y, the power will now be positive. The power will now be positive. So that when we multiply the numerators, this by this, it will be this, then this by that. This gives us 8 to the r, 1 over 3 to the power r, x to the power 8 minus 3r over y to the power 3, y to the power 8 minus 3r. So this is what we get. Now, we're interested in the term with the coefficient x squared over y squared. We're interested in such a term. Are we all able to join? I believe we are able to join direct time. Okay. So we simplify this now. So for the term with the x squared and y squared, meaning that we're going to compare the coefficients or the powers here. The power of x here, the power of x here, and the power of x here. So we have x to the power 8 minus 3x, 3r. The other side, we have x squared. So x squared is coming from there. Here the power of x is 2. Here the power of x is here. So when the bases are the same, we are just comparing the two. Since we're interested in the term with the variable x squared over y squared. So we compare the variables in this manner. We are comparing the powers. So meaning we have 8 minus 3r, 8 minus 3r equals 2. So we can now solve for r, and so we have 8 minus 2 equals 3r, so that r is equal to 2. So we have just found the value of r. Now, having found the value of r, we can now substitute. We can name this to be star. So from star, we substitute, since R is known, we have 8 choose 2, 1 over 3 to the power R is 2 times x to the power 8 minus 3 by 2 over y to the power 8 minus 3 by 2. So wherever R is, we're putting 2. And this simplifies into when we simplify this, 8 combination 2, this gives you 29. 8 combination 2 gives you 29, so you have 29 over, then 3 squared gives you 9, eh? So this will be over 9. And then we have x, when you simplify here, this is 6, 8 minus 6, it's 2. Equal here, this is 6, 8 minus 6, is 2. So we are getting x to the 2, y to the 2. So this is a term that contains x squared over y squared. This is the required term. Okay, so this is where this question ends. Any contribution? No answer. Any contribution? Ben. Helen. And Taonga Kuchipata. Taonga Kut. This time we have also Taongas from Congo. Okay. So we can go to the next screen, right? Question 4. Question 4a. I want us to solve sine x cos squared x equals sine squared x. So we have sine x. You're making noise. Can you mute? Can you mute? Eh? So we can substitute, we can make some substitution for cos squared x. Cos squared x, we write it as 1 minus c sine squared x equals sine squared x. And so when we expand here, we have sine x minus c sine power 3x being equal to sine squared x. And so putting these terms on one side, we get minus sine power 3x minus sine squared x plus c sine x equals 0. Okay. When we factor out the negative, we have sine 3x plus sine squared x minus sine x equals 0. So dividing on both sides by this negative, we have now the equation. This sine squared x minus c sine x equals 0. So we can factor out sine x so that we have sine So we have sin squared x, sin squared x plus sin x minus
Now, why
1.
have you taken the negative 1?
Pardon?
Why have you taken the negative 1?
Or I've divided by negative 1 on both sides. So we divide by negative 1 here on both sides. Then we have the product here, the product of this factor and this factor giving us 0. It implies either this is equal to 0 or the other factor inside the bracket equals 0. So we have sin x equals 0 or sin squared x plus sin x minus 1 equals 0. So from this part, from sin x equals 0, we know that if we are to solve for x here, we are going to introduce sin inverse on both sides. So we have sin inverse of sin x, and then sin inverse of 0. Here we have x being equal to, their values, sin inverse of 0 has 3 values, negative pi, which is 180, and 0 itself, and positive pi, which is positive 180. Or from the other equation, we have this minus 1 equals 0. So already we can get some values here that allows us to score some marks. So let us now solve the other equation, this part. This part we can simplify it by letting, we say let y be equal to sin x, then we have y squared plus y minus 1 equals 0. Since you are experts at completing the square, when we complete the square, we have y squared. Okay, let's complete the square together, plus y plus c 1 over 2 squared minus 1 over 2 squared minus 1 equals 0. So that we have y plus 1 over 2 squared equals 5 over 4. 5 over 4. So y plus half inside the bracket in power 2 equals 5 over 4. It's y plus half. The power 2 equals 5 over 4. Then introducing a square root on both sides, you have y plus half equals plus or minus square root of 5 over 4, which gives us plus or minus root 5 over 2. So we make y the subject. We have minus half plus or minus root 5 over 2. So we have two values.
Excuse me, sir. Can you kindly put back the first board that you are using? I didn't write something. I forgot to write something.
This screen?
Yes, the first screen. Yeah, this one, sir.
Okay.
Just give me 2 minutes. Yes, sir.
All right. So as we wait for him, those who didn't get it clearly, write some questions, but feel free to ask. This is an opportunity, isn't it? Okay. Who has a question on this? Mike. Annie Namangolo and Gabriel, are we clear?
Yes, sir, we're clear.
Okay. Taonga Banda, hope you are not in Rundas where there's no network, where network is a challenge.
Thank you, sir. I'm done.
Okay. So we go back to the screen. So we have two values here, y equals -½ minus root 5/2. So you observe that sign is not defined here. Since y is sign according to our assumption. So we have sin x being equal to -½ which we can also write as simply -1 plus root 5/2, since the 2 is a common denominator. And here also we have sin x is equal to 3 is a common denominator, -1 minus root 5. So you observe that here sin is not defined. Then you can't find such an angle because this is some value far less than -1, and sin doesn't reach that far unless the tangent function. So this which is not defined, we ignore it. We concentrate on this one, which is defined. So introducing sin inverse on both sides, we get sin inverse of -1 plus root 5/2. So at this stage now, the 2 will go, so it will just remain with x. So we have x is equal to sin inverse of -1 plus root 5/2. So now you are not allowed to use calculators. So this is where you have to end. So, and now you conclude. Therefore, x is equal to, you had gotten -π from the other equation, you had gotten a 0, you had gotten a pi. Here you have sin and the sin inverse of -1 plus root 5/2. So these are the values of x required. We are saying that we are not allowed to use a calculator, so we just have to end here for this part. Okay, any question on this one? But then let's check the condition. Were we given the domain? Let's check the domain. The domain. So, okay. So we are given the domain. Since x belongs to this interval, -π to +π. So the required values of x are, the required values of x are, I think it is all the values that were found here. Yeah, it's all the values, because this is some angle between the 30 and 40 if we use a calculator. So all these values are required. Okay, so it's fine, we can get rid of this part. So we have this as the required solution. Okay. So we can move on now to the next screen. For a 32, I want us to solve this equation. Okay, so root 3 sine x minus 2 sine x cos x. So solving this equation. So in the first place, we can factor out the sign. Factor out the sign, so we have root 3 minus 2 cos x equals 0. Since the product here of the two factors is 0, means either this is equal to 0 or the other part in the brackets equals 0. And so we write sin x equals 0, or root of 3 minus 2 cos x equals 0. Isn't it? Then at this stage, from the first one, we introduce sine inverse on both sides. We have sine x being equal to sine inverse of 0. This gives us x equals, we get the three values. We have negative pi, which is negative 180, 0, and positive pi, which is positive 180. Then from the other equation, we can, yes, Michael.
Yes, sir. I wanted to ask on the same equation. What if we take the negative side of that equation to the other side, it becomes positive, then we multiply through with sine inverse so that we remain with cos x.
You multiply through with sine inverse or getting
Yes.
sine inverse.
Yes, we multiply both sides with sine inverse, then we remain with cos
That
x.
will be a bit complicated.
Okay, so
Ah.
that one will allow you to lose some values. That one will result in you losing some of the required angles. It's equivalent to dividing by sine x on both sides, meaning that sine x, which was supposed to give you some angles, is already eliminated.
And in that scenario, that means we won't have.
Yeah, meaning
Yeah,
you won't
like-
be able to get
Like
these
we won't
three
have the
values.
value of we won't have cos theta, cos x to say.
Yeah, you're right. It's very much right. So it means you just remain with this, and so you are going to lose these three angles. Sine, you would have eliminated sine already. So mean that you won't have the three angles, but you just get one angle from this part. So you get it clear that doing like that, you enables you to lose some angles. You lose some values.
All right.
Okay. So from this part, we have root 3 equals 2 cos x. Here we have cos x being equal to root 3 over 2. So that when we introduce cos inverse on both sides, we have cos inverse of cos x. Even this side, we introduce cos inverse of root 3 over 2. Here you have x equals, this gives you 30. This gives you 30 degrees. Of course, we are considering the domain. The domain is okay. since this is the domain, negative pi over 2 and positive pi over 20. So no wonder we have not considered the other value which we could have obtained here from the other quadrant where cos is positive. Well, this is the first quadrant, and cos isn't just positive in the first quadrant. There is another quadrant where cos is positive, right? Isn't it? Which quadrant is that?
Fourth quadrant.
The fourth quadrant.
So we are ignoring that angle from the fourth quadrant because of the domain. The domain just runs from negative 90 to positive 90. Okay. So this gives us this value, which we can write as pi over 6 in per radian, in the radian measure. So considering the domain, we now have x being equal to 0 and pi over 6. Because negative pi and positive pi are not in this interval. So the only values that lie in this interval are 0 and 30. So these are the required values. And then which other one lies in this interval? Also negative, the negative of this angle. Yeah, the negative of this angle also lie in the same interval, negative pi over 6, so negative pi over 6. So this was the required solution. We can move to the next. On 4b1, we have 1 plus root of x minus x equals 2x plus 4 root. I don't know. It seems I've got an oversight here. This is a minus. Then we have a 0 this side. So we can take this component on the other side, this component here, by introducing its additive inverse so that we have it on the other side. So we get 1 plus 1 minus x root equals 2x plus 4. Then we're now going to square on both sides. So squaring on both sides gives us, we square this side and we square the other side. So when we expand on the left, we have 1 plus 2 root of 1 minus x plus 1 minus x when we expand. So you have this 1 to that power, then this by this gives us this. Then this raised to that power, the square and the square will go, so we remain with this. Because on the right, we have 2x plus 4. So when you collect the like terms here and the like, so doing that collection, okay, this will end in the next 10 minutes, but before it ends, I think we would have concluded. So collecting the like terms, we have 2 root 1 minus x equals 3x plus 2. Next, we're going to square on both sides. We're going to square this side. We're also going to square the other side. So that you have, when you expand, you have 4, 1 minus x equals 9x squared plus 12x plus 4. Collecting like terms, here you get 9x squared plus 16x equals 0, of which you can factor out x, and you have 9x plus 16 equals 0. Since the product of the two factors is 0, either each factor is equal to 0. So you have x is equal to 0 or 9x equals minus 16, so that x is equal to 0 or x is equal to negative 16 over 9. So these are the required values that you get. Of course, you can test. You can test by substituting the original equation given and pick which one satisfies the equation. Okay, any question on this one? Okay, so for today.
No question.
Pardon? No question?
No.
Okay, so for today, we can end here. Can end here.